Okay, while solving bearing and distances question, let me explain how the calculation goes. In this bearing, we are using a three-figure bearing or time bearing. The question goes like this. An aeroplane took off from an airport A on a bearing of 070 degrees and covers a distance of 20 kilometers on reaching the point B. It then changes its direction on a bearing of 150 degrees and covers a distance of 30 kilometers on reaching its destination C. Calculate A, the distance between the airport A and the destination point C. B, the bearing of the aeroplane from the starting point A. Okay? In solving the calculation, starting from the point A, we draw the four cardinal points, north, south, east, and west. From the bearing, we see that the starting bearing is 070 degrees, moving in clockwise direction from the cardinal north of point A. We start and move after getting a point very close to 45 degrees, which is half between 0 and 90 degrees. So 70 is greater than 45, so the space here will be greater than the space here, showing that 70 degrees is greater than half between the cardinal north and the cardinal east. Then we now draw the distance. This is 20 kilometers. On reaching the point B, we now draw another cardinal point, four cardinal points. Then the second bearing is 150 degrees. At that second turning, which is point B, then we start from the cardinal north and move in clockwise direction. Then we now trace 150, which is found in between 90 and 180, but very close to 180 because it is greater than the half between 90 and 180, which is 155. Having gotten that, we now draw from this point downwards. Then, as we're drawing down, we notice that the distance here is greater than the distance. So that is why we're coming down here and reaching this point. We draw four cardinal points. Then we now join the point A and point C. So that is the shortest distance between the starting point of the aeroplane and the destination point C. Then in calculating the first one, that is to find the distance between the airport A and the destination point C, which is now distance between A and C. First, we find the angle ABC. Angle ABC, this angle, which is Y, angle Y, and angle X. So, to find angle Y, we notice that angle Y is alternate to 70 degrees. That is angle Y plus 70 degrees. To find X, we notice that 150 plus X will give us angles on a straight line. Removing 150 from 180, we have X. So that is how we got X here. Then, in angle ABC, 70 plus 30 is 100 degrees. Now, to find the distance between the starting point and the destination point, which is AC, we now use a cosine rule. Sine AC squared equals A squared small, which is the side facing BC, plus C squared, which is the side facing AB, minus 2AC cos B, which is angle ABC. Then we notice that the side of small a is 30 kilometers, C is 20 kilometers, and B is 100 degrees. Then replacing the whole thing back to the formula, we now have the 30 squared plus 20 squared minus 2 times 20 times 30 equals 100. Then 30 squared is 900, 20 squared is 400, minus 2 times 20 times 30, which is 1,200. Then in cos 100, 100 is in the second quadrant using quadrant rule. We now notice that 100 is in the second quadrant and cos is negative in the second quadrant. So we now have to apply the quadrant rule, which is capital bracket minus cos. Since cos is negative in the second quadrant, bracket 180 minus 100, we now have minus cos 80 degrees. Then this 900 plus 100 gives us 13 minus 12 times minus cos 80 degrees. Then cos 80 degrees is this. Then bring down minus. Then we now multiply minus times minus is plus. 12 times 0.1736 will give us this. Adding together, we have this. Then to find AC, this is square. Crossing it becomes square root. Square root of 1,508.3778 will give us 38.8378. Leaving it in 2 decimal places, we have 38.84 kilometers. That is the distance between the starting point and the ending point of the aeroplane. Then calculating number B, which is the bearing of the aeroplane at point C from the starting point A. Going back to the diagram, the bearing is from this cardinal north A of point, cardinal north 0 from point A. We move clockwise and down the line that connects point A and point C. We notice that the bearing is 70 plus theta. Now, we find theta. Finding theta, we consider triangle ABC. In triangle ABC, theta is the angle at A, point A, which is angle, theta is equal to angle BAC. So we use sine rule to find theta. Using phi rule to find theta, we have sine A over small a equals sine B over small b. And that is what we did here. So we have what is it? Yeah. The bearing, which is 70 plus theta, like I said, sine A over A equals sine B over small b. Then small a is 30 kilometers, which is given. Small b is 38.84 kilometers, which is calculated above. Angle B equals 100 degrees, also calculated above. Angle A is what we are looking for, which is theta. Then from the formula given, sine A over small a equals sine B over small b. We make angle A the subject. This crossing will be A sine B over small b. Then making A the subject, sine crossing becomes sine inverse of the whole thing in bracket. Replacing the values back, we have 30 for small a, 100 for capital B, 38.84 for small b. At this point, 100 is in second quadrant and the sign is positive in the second quadrant. That is why we go straight. We now have 30 times sine 100 will give us this. This time this will give us 29.544 over this. Then this divided give us 0.7407. Then sine inverse for 0.7607 will give us 49.5259. Rounding to the nearest degree, we have 50 degrees, which is, this is 5, call it 1, add this, it should be 10, 0. Carry 1, drop it here, 5, will give us 50 degrees. Then from the bearing, which is 70 plus theta, but theta equals angle A, therefore the bearing equals 70 degrees plus 50 degrees, giving us 120 degrees, and that is the bearing of the aeroplane at the destination point from the starting point A. So that is it. Thank you.